Are you confused between continuous and discontinuous measurement? Okay, let's talk about it. Hey there! In this short video, we'll learn some basics about measurement along with practical real-life examples. Now, you probably already know what measurement is. Yep, it's the same measurement you use when you're baking or the same measurement that tells you how much gas is left in your car. The term measurement is simply a way to quantify or give a numerical value to objects and events. It's used in various sciences to measure various scientific phenomena. In applied behavior analysis, measurement is used to calculate behavior and to provide a numerical value to behavior. Measurement in ABA is broken up into two different sectors, continuous and discontinuous. For the purpose of this video, we'll only be focusing on continuous measurement. Continuous measurement means observing and recording every instance of a behavior as it's happening, as in there's no breaks in the data collection. This will make more sense when you learn what discontinuous measurement is. Just a reminder, an instance of a behavior is also referred to as a response. So, for example, a behavior might be lifting weights at the gym, but an instance or response is for every single time you lift that weight. Just to keep that in mind. In case you hear me later on switch between using instance or response, that's what I'm referring to. With continuous measurement, there are three-dimensional quantities. There's repeatability, there's temporal extent, and there's temporal locus. Let's talk about repeatability. Repeatability is for behavior that can be counted. And there are three types of measurements you can use with repeatability. There's count, there's rate, and there's celeration. Count is a measurement that refers to the number of responses of a specific behavior. Some people also use the word frequency. So, for example, if we're looking at the behavior of sneezing, every time you sneeze can be counted. Or if you are taking a walk and walking is the behavior, you can count the number of steps you took. Another example is eating. While you're eating, you might measure every single bite. So that's what count is. It's the number of every single response of that behavior. Rate, on the other hand, it's kind of like count, except it's divided by the time it was observed. Let's say you're observing someone for 5 minutes and they sneeze 10 times. So now you have your count, which is 10, over the time of the observation, which is 5 minutes. If you divide the times that the person sneezed by the amount of time they were observed, you'll be able to get a rate. So in our example, 10 times over 5 minutes will give you 2 sneezes per minute. That's your rate. Let's go back to the example with walking. You can get the rate of how many steps you take if you take the number of steps and you divide it by how long you walk. So maybe you took 1,000 steps in 10 minutes. The rate would be 100 steps per minute. Celeration is a bit tricky. It's basically the rate across a specific amount of time. It checks how the rate of responding will change over time. Celeration is classified by either acceleration or deceleration. And you may be familiar with these words in reference to driving a car. When you step on the gas, you're accelerating. But when you hit the brakes, you're decelerating. In the same respect, when the rate of behavior is going up, then it's accelerating. And when the rate of behavior is going down, then it's decelerating. So let's think of an example. Let's say you track the number of steps you take during your walks across 4 days. First, you would want to find the rate of your walks for each day. You would take the number of steps you walked that day and divide it by how much time you walked. Here's an example. Monday, you averaged 100 steps. Tuesday, it was 200. Wednesday, 400. Thursday, 800. This is an example of acceleration because you can see that the rate of responding is doubling each day. So the acceleration is times 2. Now let's get into measures of temporal extent. Temporal refers to time. The word extent means length. So we are looking at the length of time that a behavior occurs from its onset until it ends. Please take note, the only measurement method related to temporal extent is duration. And with duration, there are two types of duration: total duration per session, and we have the duration per occurrence. Total duration per session basically means the amount of time that behavior is occurring for the entire time you're observing. Whereas duration per occurrence refers to each instance or response of the behavior and how long it's happening. Let's look at an example. So, when finding the duration of drive time, we can either measure the total amount of time we drove that day, or we can measure the duration of each ride we took, starting from when we turned on our vehicle and when we reached our designated location. Here's an example of Anna's drive time for today. Her drive time for today was a total of 1 hour. That 1 hour would represent the total duration per session. However, if we break up each single ride she took, that would count for duration per occurrence. Breaking up each time represents the duration per occurrence, and if we total all of her drive time, that will represent the total per session. Let's look at the last dimensional quantity of continuous measurement, which is temporal locus. Again, temporal relates to time, and the word locus means a particular point or a particular position. So, temporal locus is a particular point in time. Temporal locus focuses on when a behavior occurs in respect to another event or another behavior. The two measures under temporal locus are latency and interresponse time. Latency is the time between a given stimulus and the start of a behavior. For example, when you go to a restaurant, from the time your meal is placed in front of you until the time you start eating, that time between represents latency. Another example is at work. So let's say I go to work and I clock in, boop, and I sit at my desk and I drink coffee and I chat with my coworker before I actually start. Let's say my first thing was to open an email, or my first thing is to enter a meeting. That time between represents latency. Let's talk about inter-response time, also known as IRT. IRT is the time between one instance of behavior ending and the next instance beginning. So let's go back to that example about sneezing. We were observing someone for 5 minutes and they sneezed 10 times. We found out that the rate was 2 times per minute, but it may not always look like someone literally sneezing twice in 1 minute. So here's an example. The first time the person sneezed and the second time they sneezed, there was 1 minute in between them. But if you looked at the third time they sneezed and the fourth time they sneezed, there was 15 seconds. Those time in between each sneeze represents IRT. Now, as you can see, not all measurement is created equal. There are different reasons why people choose to use different measurement options when it comes to behavior, and it's usually tied to what the goals are concerning that behavior. For the purpose of the video, I was going to simply focus on continuous measurement. The pros of continuous measurement method is that it really allows for you to get more precise data on that behavior. And it's crucial for making informed decisions about interventions because you get a full picture of what that behavior looks like. Continuous measurement is great because it allows us to gather very precise data. However, one of the cons of continuous measurement is that it can really be difficult, especially if the behavior happens a lot or if it happens for long periods of time. It's also very hard if the behavior it's very tricky and difficult to see the start and the end. All right, thanks you guys, and I'll see you next time.